Hello everyone, my name is Savneesh Tiwari, Assistant Professor in Civil Engineering Department at Sri Ram Swaroop Memorial College of Engineering and Management, Lucknow. Today I am here to take a lecture on a topic related to environmental engineering. Subject code is KCE 603. So this is first module and we are going to just start the first unit, which is totally related with water demand. So in this module we will discuss fresh water, what is water demand and how this demand varies. So before coming to all this topic, we have to know what is fresh water. So we are going to start with fresh water, and at the end of this lecture you will be able to understand various types of water demand and how this water demand varies. So starting with our first topic, that is fresh water. So what is fresh water? First question arises here, that what is fresh water? So fresh water is nothing but it is a naturally occurring liquid or frozen water. What does it means? That it will occur in liquid form or as well as frozen form, and the criteria which separate it from other water is the amount of solids, and that contains low concentration of dissolved salts. And what will the concentration of these solids? The concentration of solids are less than 1000 milligram per liter of dissolved solids, and these solids are what? These solids are basically in the forms of salt. So we all are also aware about salty water. So this is totally different from fresh water, and the concentration of solids in the water is less than 1000 milligram per liter. In the slide a picture is showing the amount of global water. We are going to talk about total global water. The global water can be distributed into following three parts. First one is water present in ocean, which is totally salty. Another one is saline water, and the next one is to fresh water, which is of our concern. So we are only talking about this water, which is 2.5% of total global water, and further this total fresh water will be further bifurcated on the basis of source in which it occurs. So it will be in the form of solid that I already discussed, that is frozen water. So that is 68.7% in the form of ice. Another one is present in groundwater, which is about 30.1%, and on the surface approximately 1.2% water is resting. So this is all about fresh water. So next is, what is water demand? So the question arises is, what is water demand and how we are going to measure it? So basically water demand is nothing. Water demand, we are going to talk about the quantity. What we are going to talk? We are going to talk about quantity, and in the terms of volume, and the quantity is in the term of volume. So water demand is nothing but it is the volume of water required by a user. How much amount you need is the water demand, and it depends on various parameter which we will discuss in next slides. So water demand is a quantity or volume of water required by a user to satisfy their needs, and the needs may be vary. Just like if at a domestic level, what will be our need? Our need will be cooking, bathing, drinking. But if we are going to discuss about industries, their needs will be different. So the need of a person varies, the need of a user varies depending upon the requirement or the place where we are going to consume water. So at home the water demand will be the in form of cooking, drinking, bathing, cleaning, and for the laundry purpose. This is the basic requirement. We can also call it as a domestic water demand. In institution or parks in a market area, for what purpose we are going to consume water? We are going to consume water for watering of public parks or watering of gardens, public fountains, sprinklings and road washing. These are the water requirement at an institute level in a park or a market area. And we are also aware that at the time of emergencies, water is also required for the purpose of firefighting, and certain water are also lost during the transmission. If we are going to supply the water from a plant to the consumer, certain amount of water are also losses. So this loss also come in water demand. So why these things are necessary? These things are necessary, or what is the need that one should be aware about water demand. Basically, if we are going to design a structure, then we have to know that for what quantity we have to design it. So that is the basic purpose behind knowing water demand, knowing the quantity of water which we need to satisfy the needs in future. So estimation of water demand is necessary. If we fails to properly estimate it, there will be problem. What will the problem? The problem will be in two forms. Either it will be inadequate design, or it will result in uneconomical and inefficient water supply system. And these two conditions arises on the basis of two different estimates. One will be the underestimation. If we are estimating water less than the required amount at the time of supply or during the time of supply, then the structure will result in inadequate design. If we are going to overestimate it, then what will be happen? For overestimated water demand, we have to create a huge structure in respect to just equivalent or required amount of water. So it results in uneconomical and inefficient water supply system. So these are the certain needs and basics of water demand. Next important topic is per capita demand. So what is per capita demand? Basically, this term can be understand by formula, or if we are going to understand it theoretically, then it can be annual average amount of daily water. Annual average amount of daily water, what does it means? For example, if a person is consuming 360 liters of water throughout the year, then what will be the annual average daily water? It will be 360 divided by 360. It means that total amount of water consumed in a year divided by total days. So it will be the average daily water demand. So average daily water required by a person is known as per capita demand. In order to understand it, there is also an expression. So what is V? V is the total amount of water required in a city. Why we are talking about a city? As we all know that if we are going to design a water supply system, then it's obvious that it will supply water in a certain areas, and these certain areas have certain population. So V is what? V is the total amount of water which that area will consume in a year. P is what? P is the total population of city. So per capita demand will be what? Total amount of water required divided by 365 into total population of the city. So per capita demand will be V divided by 365 into P. And what will be its units? Its unit is liter per capita per day, or we can also say it as LPCD. So in short form, we always notice that per capita demand is mentioned as 150, 450 or 10 LPCD. So that is liter per capita per day. Okay. Next one is, what are various types of water demand? So depending upon the different places where we are going to consume water, the water demands are further classified into domestic water demand, commercial and industrial water demand, demand for public uses, fire demand, and water required to compensate the losses. So these are the classifications or types of water demand. So coming to our first water demand, that is domestic water demand, which I just discussed कि जो हमारा वाटर डिमांड होता है बेसिकली वो कहाँ पे हम कंज्यूम कर रहे हैं. तो इन डोमेस्टिक वाटर डिमांड द वाटर रिक्वायर्ड इन रेसिडेंशियल बिल्डिंग्स, so the water supplied in residential building will comes under this category. And what are the purposes? The purposes are drinking, cooking, bathing, cleaning utensil, floor cleaning, toilet flushing comes under this category. And this type of water demand depends upon the living condition of a consumer. What will happen? Depending upon the living conditions, the amount of water required will varies, as high income group persons consume more water with respect to low income group persons. This can also be seen in next slide. So here is a tabular representation which shows the distribution of water consumption at a domestic level. So basically this is minimum domestic water consumption for Indian towns with a full flushing system, and this is a minimum domestic water consumption for economical weaker sections and LIG colonies. Means in low income groups the distribution will be like that, else there the distribution will be like this. So there is a variation in the amount, and the total variation is from 135 LPCD to 200 LPCD. So that is 200 liter per capita per day. So these all are the distribution. For drinking purpose we are consuming 5 LPCD, for cooking purpose 5, bathing 75, washing of clothes 25, washing of utensils 15, and washing and cleaning of houses again 15, gardening and flushing of water closets is 45. So when we sum up we will get 200 LPCD. This is for high income groups, and while in a case of economic weaker section persons and LIG colonies the total consumption is 135 LPCD. For drinking it is 5 LPCD, for the purpose of cooking again 5, bathing it's 55, washing of clothes it's 20, washing of utensils it's 10, and cleaning of houses is 10, and in WCs we are going to use 30 LPCD. So that comes 135 liter per capita per day. So this is the distribution of or breakup of domestic consumptions. Next one is commercial and industrial water demand. In commercial and industrial water demand we will covering the water consumption at a commercial and public establishment. Water commercial and public establishment. Commercial and public establishment includes offices, hospitals, hotels, restaurants, cinemas, schools, and factories or industries. And the amount of water required here will depends upon the number of industries present in that area or number of establishment present in that area, nature of town, how much number of hotels are present there, how much number of hospitals are present there. So on that factors it depends. So here is a table which shows the water consumption at different institutes. So basically first one is a hospital. So here the consumption of water is 450 per bed or 350 per bed. And that is what is 450 and what is 340. it is actually depending upon number of bed exceeding. So that is 450 is what, 450 liter per capita per day. If in a hospital number of beds are more than 100, then the demand will be 450 liter per capita per day, and if the number of beds are less than 100, then the amount of water required is 340 liter per capita per day. So on, for different institutes we have mentioned here what are the required amount of water. So for day schools or colleges, the amount of water is 45 LPCD. So these are the various institutes, and these are the amount required by the people, or the amount totally required in that particular institutes per capita per person per day. Okay. Next one is again a table showing the amount of water required in various industries. So first one is automobile industry, and what is this? Basically this represents the units of production. Talking about automobile, the production unit will be vehicles. In distillery industry, the production will be in kiloliters. Fertilizer, the production will be in tons. So these are the units which shows the amount which we are going to produce, or which the industries are producing, in which unit the production is there. So talking about automobile industry, the amount required is 40, and what is 40? That is kiloliters per unit. एक यूनिट के प्रोडक्शन पे जो हमारा यहाँ पे वाटर डिमांड है वो कितना आ रहा है आपको देखने को मिल रहा होगा, दैट इज 40 किलोलीटर पर यूनिट. उसी तरीके से हमारी जो बाकी इंडस्ट्रीज हैं, जैसे डिस्लरी है, फर्टिलाइजर है, लेदर है, पेपर इंडस्ट्री है, आपके स्पेशल क्वालिटी पेपर है, स्ट्रॉ बोर्ड्स है, पेट्रोलियम रिफाइनरीज है, स्टील, शुगर एंड टेक्सटाइल, उनके करस्पॉन्डिंग्स यहाँ पे जो दिया गया है, वो जो यूनिट्स प्रोड्यूस हो रही हैं वो किस काउंट में प्रोड्यूस हो रही हैं या कितने अमाउंट में प्रोड्यूस हो रही हैं, क्या उनको हम वॉल्यूम्स में मेंशन कर दे सकते हैं या आप उनको मास में मेंशन कर सकते हैं. तो उसके करस्पॉन्डिंग हमारे ये क्या है, जो नीड्स है उनकी, कि एक्चुअल में हमें कितना वाटर वहाँ पे सप्लाई करना चाहिए. सो दैट्स कम्स अंडर इंडस्ट्रियल वाटर डिमांड. नेक्स्ट वन इज अ डिमांड फॉर पब्लिक यूजेस. सो अगर हम बात करें किसी एक एरिया की, तो हमें ये देखने को मिलता है कुछ पब्लिक यूटिलिटीज़ होती हैं वहाँ पे. पब्लिक यूटिलिटीज़ में क्या क्या आती हैं? एक तो बेसिक आप देख सकते हो कि वाटरिंग होती है किसकी, जो आपके पब्लिक पार्क्स हो गए, पब्लिक गार्डन्स हो गए, उनकी. कुछ फाउंटेन्स लगे होते हैं, अगर आप जंक्शंस पे देखो तो वहाँ पे फाउंटेन्स लगे होते हैं, तो उन फाउंटेन्स के लिए भी वाटर की नीड होगी. हमें रोड वॉशिंग करना होता है तो उसके लिए भी वाटर की ज़रूरत होगी. तो उन्हें अगर हम वहाँ पे सैनिटरी मेंटेन कर रहे हैं तो उस पर्पस के लिए क्या है, हमें कुछ वाटर वहाँ पे सप्लाई करना पड़ता है. सो in this demand we will discussing, we are going to cover these particular things. And in India the amount not exceeding 5% of the total consumption means जो हमारा total consumption है उसका 5% हम क्या करते हैं, प्रोवाइड करते हैं demands for public uses, and that value is usually 10 liter per capita per day. Okay, so next one is fire demand. So fire demand, in fire demand the amount of water required for the extinguishing the fires at the time of emergency, and how we are using it. For the purpose of using the water, fire hydrants are provided, and fire hydrants are provided at an interval of 100 to 150 मीटर. तो यहाँ पे क्या होता है, फायर हाइड्रेंट्स प्रोवाइड करते हैं जो कि आपका 100 to 150 मीटर के इंटरवल्स पे होते हैं, और जनरली देखा ये जाता है कि ये फायर हाइड्रेंट्स जो हमारे रोड्स होते हैं उनके साइड में प्रोवाइड किया जाता है, जिससे कि अगर इमरजेंसी कभी हो रही है तो हम वहाँ से वाटर क्या कर सकें, ईजिली उस पर्टिकुलर आप प्लेस तक पहुँचा सको जहाँ पे इंसिडेंट हुआ हो. ओके, तो बेसिकली यहाँ पे होता क्या है कि हम जब बात करते हैं कि रिक्वायरमेंट क्या है, हमें कितना अमाउंट इस पर्पस के लिए बेसिकली सप्लाई करना चाहिए, तो एज पर IS 9668-1990 किसी भी टाउन में हमारा जो फायर फाइटिंग के लिए वाटर दिया गया है, दैट शुड बी 1800 लीटर पर मिनट। और कितनों के लिए, अगर हम ये बात करें कि फॉर हाउ मच पॉपुलेशन, देन दैट विल बी 1800 लीटर पर मिनट फॉर एवरी 50,000 populations. Per 50,000 population, we are going to provide 1800 liter per minute of water, or thereof for a town up to 3 lakh population. And addition, और उसके अलावा क्या करते हैं हम, 1800 लीटर पर मिनट फॉर एवरी 1 लाख ऑफ पॉपुलेशन मोर देन 3 lakhs. अगर उसी टाउन की पॉपुलेशन क्या हो जाए, अगर हमारी 3 लाख से ऊपर मीन्स पॉपुलेशन अबव देन 3 lakhs, देन हमें क्या करना होगा, हर 1 लाख के पॉपुलेशन इंक्रीज के लिए हमें जो है 1800 लीटर पर मिनट का एड ऑन देना पड़ेगा. एंड द स्टोरेज विल बी फॉर हाउ मच आर 4 to 24 आवर ड्यूरेशंस. और वो ड्यूरेशंस पे जो भी स्टोरेज होंगी, तो जो हमारा वहाँ पे वाटर का जो सप्लाई होना चाहिए, दैट शुड बी एट दिस रेट, दैट इज 1800 लीटर per minute. Okay, so coming to next, according to CPHEEO manual, the amount of water required for fire demand is taken as a coincident draft. In next slide we will covering what is coincident draft. So that should be as a coincident draft along with a normal supply to the consumer as assumed. means हमारी जो भी coincident drafts होंगी, हम क्या करेंगे, उन फॉर्म में भी प्रोवाइड कर सकते हैं. एंड और दूसरा हमारे पास क्या है, जस्ट फॉर्मूला के बेसिस पे है, और उस फॉर्मूला के बेसिस पे बात करेंगे, तो दैट इज 100 अंडर रूट ऑफ p, वेयर p इज द पॉपुलेशन इन thousands. सो एंड दैट इज फॉर 50,000 population. Okay, coming to empirical formulas, there are 3 formulas or more than 3 formulas according to which we can calculate the fire demands. So here first one is the Booston formula. According to this, fire demand will be Q equals to 5663 root P. Q will be, according to Cushing's formula, Q will be 3182 root P, and according to Freeman's formula, Q will be 1136 P by 10 plus 10. And what are the units? Q is in liter per day, Q is in liter per minute, Q is in liter per minute, and P is the actual population in the thousand. So P is the population of that particular town. And according to National Boards of Fire Writers formula, for centrally congested high valued city, population less than 2 lakhs, Q will be 4637 under root P bracket 1 minus 0.01 root P. And for population greater than 2 lakh, we are going to use this formula for the estimations of fire demand. And in residential cities, for small or low building, Q will be 2200 liter per minute. For larger or higher buildings, Q will be 4500 liter per minute. High value residence apartment, Q will be 7650 to 13,500, and 3-stored buildings in density of built up sections, Q will be 27,000 liter per minute. So these are the values which we will include in fire demand while at the time of designing. So next one is a water required to compensate the losses, and these are in the forms of leakages, in the forms of unauthorized water connections, and losses due to various miscellaneous reasons, and these miscellaneous reasons are unaccounted. So for the purpose, we are going to provide 15% of total consumption of the total demand. Next one is variation in water demand. So in this we are going to study how the demand varies. Basically what will happen, water demand will not be constant, it will be varying in different seasons, different months, in different days, in different hours. Even we can say that there is a variation in different minutes. So this can be grouped into following 3 parts. First one is seasonal variation, second one is daily, and third one is a early variation. So in seasonal variation, the demand varies seasonally, and this can also be seen that what happen in summers. In summers, water consumption increases and water demand also increases. The demand increases by 30 to 40% with respect to our annual average water demand. मीन्स जो हमारा समर में वाटर डिमांड होता है हमारे एनुअल एवरेज डिमांड से 30 to 40% ज़्यादा होता है. एंड व्हाट इज द रीज़न बिहाइंड दैट? दैट more water is consumed for the purpose of drinking, bathing, washing and so on. And what will happen in winter season? In winter season our consumption decreases, hence we can say that water demand decreases, and the decrease in water demand is about 20% with respect to our annual average demand. And what will happen in rainy season? In rainy season the water is also available for the purpose of gardening. We have not to supply excess water, or we have not to supply water for the purpose of gardening. So in rainy season the amount of water get reduced. Okay. So this is all about seasonal variation, and this is all about our today's lecture. In next lecture we will going to discuss the remaining variations. These are the references which I have referred for the preparation of the content. First one is a water supply engineering AKtU, and next one is a manual CPHEEO, Ministry of Urban Development, Government of India, New Delhi. Okay, thank you.